Hey, it's me, Mr. Sklar, with some explanations for the transformations test. This is the first time I'm making one of these things, so it might be a little bumpy, but bear with me and let's see how it goes. So number one, which type of transformation is shown in the diagram below? And let's see what we have. We've got the pre-image here, and the only way we can get the pre-image over to the transformed image is to take the whole thing and move it 3 units to the right. We're going to slide it 3 units to the right, so that is a translation 3 units to the right. The next one says if point x, 2, negative 3 was rotated 180 degrees about the origin, what would be the coordinates of x prime? So we have 2, negative 3 right about there, more or less. And if we rotated 180 degrees, the signs of the x and y are both going to become reversed. So it's going to be negative 2. Where's my little pointer thingy? There we go. Negative 2, 3. So negative 2, 3 is where that is going to be. And it's right there. About. Somewhere over there. Alright, let's keep going. So, well, how do I do this? Okay, the next question says an animal cell is, and then it gives us this complicated looking number, is this many meters wide. How is this number written in scientific notation? That's really just a fancy way of saying how do we write this number here in scientific notation. So let's see, we have to move the decimal point over 1, see if I can get that. Oh, there we go. We have to move the decimal point over 1, 2, 3, 4, 5. Let me just back that up because I can't really see what I'm doing here. We want to stop between the 2 and the 6, right? Because we need at least one digit to the... Sorry, we need exactly one digit to the left of the decimal point. Draw. Okay, so 1, 2, 3, 4. So we have to move the decimal point 4 places to the right, or multiply this by 10, 100, 1,000, 10,000, and then we get 2.678 times 10 to the, and since we made this number bigger when we turned it into this, then we're going to have to make this number smaller in order to keep it balanced. So it's going to be 10 to the negative 4. And that will give us choice number, that's a letter A. Okay, so here we have 6 to the 15th over 6 to the 3rd, same base. So when we have the same base, then we subtract the exponents in order to divide. So it becomes 6 to the 15 minus 3, or 6 to the 12th, which is choice A. And then the next one says that the orientation of triangle ABC was not preserved. And we know that the only transformation that does not preserve orientation is a reflection. So this one has to be a reflection. Let's see, this one says which transformation is shown below. And once again, the only transformation that is going to map one of these parallelograms onto the other, so if we want to map this onto this, or we could go the other way, it doesn't matter, is going to be a reflection. Notice how each point is the same distance as its corresponding point from the line of reflection, which would be in this case the x-axis. This says perform the indicated operation, and hopefully as soon as you see these powers of 10 multiplied by other things, you're thinking to yourself scientific notation. So we can take this and regroup this into 2.4 times 3. There we go, it's a little better. times 10 to the 5th times 10 to the 9th. And let's see, 2.4 times 3 is going to be 7.2 times, and 10 to the 5th times 10 to the 9th, we're multiplying, same base, so we keep the base, and we add the exponents because now we have 14 tens all multiplied together. So this is going to be choice B. Alright, now we have which of the following transformations create a figure that is similar but not congruent to the original figure. Translation is going to be congruent because you're sliding it, and that doesn't change the size or the shape. Rotation is going to be congruent because you're rotating it, and that doesn't change the size or the shape. So we're left with dilation, which exactly what a dilation does is creates a similar figure. The size will change, but excuse me, but the shape will stay the same. So that's got to be C. And then number 9, which transformation represents a dilation? Some people had some trouble with this one. Remember, in order for it to be a dilation, whatever you're multiplying this x by to get the transformed x, you have to multiply the same thing by the y in order to get the transformed y. And since we have to multiply 2 by 3 to get 6, and if we multiply this negative 3 by 3, it gives us negative 9, not 1. We know that that can't be the answer. So let's see, if we go to B, 2 times 4 would give us 8. So then we would have to multiply negative 3 times 4, and that would be negative 12, not negative 6. So we know that it cannot be B either. Let's have a look at C. To get from 2 to negative 2, we'd have to multiply by negative 1 there. And if we multiply negative 3 by negative 1, it gives us 1, not negative 3. I'm sorry, it would give us positive 3, not negative 3. Boy, it's hard to do this with all the pointing and changing the pen and the pointer and all this and talk at the same time. Oh, there we go. So let's check out D. 2 times 2 would give us 4. So will negative 3 times 2 give us negative 6? Yes, we have to multiply them both by 2. So the answer is going to be D. Number 10, if an image with these coordinates right here, 3, 4, and 1, 2, and negative 1, 0, is dilated using a scale factor of 4, what are the coordinates of the new image? Well, that means we're going to multiply every single one of these values, each one of them, we're going to multiply by 4. So 3 times 4 is going to give us 12. 4 times 4 is going to give us 16. So one of our points is 12, 16. 1 times 4 is going to give us 4. 2 times 4 will give us 8. And then negative 1 times 4 will give us negative 4, and 0 times 4 will still give us 0. So we're looking for the answer choice that has these coordinates, and the only one that does is answer choice B. So that's going to be our answer. Point A, negative 3, 2, is reflected in the line x equals negative 1. And then it wants to know the coordinates of the transformed image. So here is negative 3, 2, and it said that was reflected in the line. Let me see, was that x equals negative 1 or y equals negative 1? Okay, it was x equals negative 1. So since it was x equals negative 1, I know x equals negative 1 is right about here. So I know this is going to be my line of reflection. X equals negative 1. And then I see, if I count, I've got 1, 2 units between the line of reflection and the pre-image. So then I know I need to have 1, 2 units between the line of reflection and the transformed image. So the transformed image is going to be right here at, let's see, what would that be? That would be 1, 2, right 1 up 2 from the origin. So that's going to give us 1, 2, and 1, 2 is choice B. Okay. Let's see, number 12. Rectangle R undergoes a dilation with a scale factor 0.5, and then a reflection over the y-axis. The resulting image is rectangle S. What statement about rectangle R and S is true? So let me see. So we're going to have R, and R is going to be dilated. Whoops. There we go. R is going to be dilated, and then it's going to be reflected over the y-axis. So after it's dilated, it's going to be reflected. So let me think of a few things I know. I know the size is going to be different if it's dilated, and I know the orientation won't be the same if it's reflected. And then we will have triangle S, or sorry, rectangle S. So let's see. A says they are congruent and similar. I know that can't be true because the size changed, so they can't be congruent. B says they're similar but not congruent. That works for me so far. Let's check out C. They're congruent but not similar. They're definitely not congruent because R was dilated. And they're neither congruent nor similar is not right because they are similar. A dilation preserves shape and angle measure. And therefore the answer is choice B. 13 says if point B is dilated by a scale factor of 1/2, what are the coordinates of the transformed point? So that means we have to take -2 and multiply that by 1/2. And we have to take 4 and multiply that by 1/2. And -2 times 1/2 is going to give us -2/2, or -1. And 4 times 1/2 is going to give us 4/2, or just good old 2. So I know that my points are going to be -1, or my coordinates for the point, rather, are going to be -1, 2. Let's see. Number 14 says point R at 4, -2 was dilated, and its image was graphed as R prime. What was the scale factor? Well, to find the scale factor, we know we have to take the transformed coordinates and divide the transformed coordinates by the original coordinates. So in this case, it's going to be 12, -6 divided by 4, -2, because 12, -6 is the dilated image, and 4, -2 is the original image. And if I do, let's see, 12 divided by 4, 12 divided by 4, that's going to give me 3. And I should get the same thing for the y value, -6 divided by -2, that is also going to give me 3. So I've confirmed that the scale factor is 3. Okay. And number 15. Which series of transformations takes triangle A onto its image, triangle B? So first thing I have to make sure I do is pay attention to which is the pre-image and which is the transformed image. And it tells me that A is the pre-image and B is the transformed image. So let's see what happens. If I reflect that over the x-axis, it's going to end up here, and then 2 units down. So it can't be choice A. So let me get rid of that. And what happens if I reflect over the y-axis? If I reflect over the y-axis, it's going to end up kind of right about here. something like this. But it's going to be a little too high, so then it has to translate 2 units down. That's looking pretty good. I want to check the other ones just to be sure, though. So, translation 2 units down, and 90-degree rotation about the origin. No, that wouldn't work. If this were rotated 90 degrees about the origin, it wouldn't look like a reflection of itself. Different parts would be pointed in different directions, so it can't be that. Translate 12 units right and 90-degree rotation about the origin. Well, if I translate it 12 units right, it's going to end up someplace over here in the first quadrant. And a 90-degree rotation about the origin is going to bring it down to the fourth quadrant. So it can't be that one either. So I was correct when I thought that it was B. And now on to the extended response. Describe the transformation that maps ABC onto ABC prime. Now, once again, we have to make sure we're going from the correct, the pre-image to the image. So it's going to be from here to here, ABC to ABC prime. And let's see, I'm noticing that each point is exactly the same distance as the corresponding point from the line of reflection if it were reflected. So this is a reflection, reflection over the x-axis. And then the next question asks for the transformation that maps ABC prime onto ABC double prime. So that's going to be this one over here. It wants to map this. Hey, go away, color thing. Yeah, wants to map this onto this. So what's going to do that? It's going to move over. I think it's going to move over 7. Let's make sure, if I remember right. So 1, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6, 7. Oh, it's 8. So it's 8 left, and 1, 2, 3, 4, 5 down. So it's left 8 and 5 down. So that's the transformation there. I can write that in. Oh, that's a nice color. And is there a single transformation that would map triangle ABC directly onto triangle ABC double prime? There is not. Nothing's going to do that. Okay, next question says, translate triangle SUN along vector XY and then label the image SUN prime. So I'll zoom in a little bit here. So let's see what this vector is doing. This vector is saying to get from X to Y, I have to go 1, 2, 3, 4 up and 1, 2 to the right. So I'm going to have to do that with each of these points as well. So let's see, if I start at S and go 1, 2, 3, 1, 2, 3, 4 up and 2 to the right, S prime is going to be right about there. And then if I take point U, 1, 2, 3, 4 up, 2 to the right, U is going to end up right over there, U prime, and N is going to go 1 to the right, 2 to the right, and 1, 2, 3, 4 up, and then we're going to have N prime, and then I need to connect them as best I can. I wish I had a way to make straight lines on here, but I don't. And that's the transformation. Are they congruent? They are congruent, and the way that you know that is that translations preserve size and shape, or translations preserve congruence. Okay, point R was translated to become point R prime. So I like to make my little sketch so I have an idea of where things are. And I can say point R is, I don't know, maybe about here at 4, 1. And R prime is at 6, 5. Okay, so I know to get from 4 to 6, I had to go 2 to the right. My x value went up from 4 to 6, so that's going to be 2 to the right. And then my y value went up from 1 to 5, so I know that's going to be up 4. And then it wants me to take this point, negative 4, 3, point S. Negative 4, 3 is point S. And it wants us to do the same thing that we just did over here. So it's going to go, again, 2 right and up 4. So if we go 2 right, let's see, we go 1, 2 to the right, 1, 2, 3, 4 up. Then we get this point right here, which is S prime, and I can see that the coordinates of S prime, if I start at the origin, it's going to be 2 to the left, so that's negative 2, and then 1, 2, 3, 4, 5, 6, 7 up, so it's going to be negative 2, 7. Okay, let's check out these triangles to see if they are similar. Now, we have an 80-degree angle on this one, and we have an 80-degree angle on this one, and we have a 25-degree angle here, and a 25-degree angle here, and since these two angles are the same, and these two angles are the same, then we know that A and A prime are also going to be the same, because the angle measures of all three triangles have to add up to 180 degrees. So, ooh, yellow. So we know that they are similar triangles because they have two corresponding ESPONDING angles. And if they both have 2, we know they both have to have 3. And if all of the angles in both shapes are the same measure, then we know that they're similar triangles. All right, almost done. Given triangle HAT at these coordinates, first it wants us to rotate it clockwise. So in order to rotate it clockwise, remember you want to turn your paper clockwise and have a look at where those coordinates are when they end up in the third quadrant. And if I turn my paper clockwise, I can see that A prime is still going to be at 0, 0. Still there. But when we go clockwise, this T is going to come down there. So that's A prime. So T prime is going to be at 0, negative 2. And then we can see that when we turn everything clockwise, H is going to end up there. So H prime is going to be at 3, negative 2. So if I did that right, we've got H prime is 3, negative 2, and A prime is 0, 0, 0, and T prime is 0, negative 2. And then, of course, we have to actually plot it. We can't just describe where it is when it says to perform a translation or a rotation or a reflection or a dilation. We have to actually do it on the paper. So here we go. A prime is still going to be right here at the origin. Make this a little bigger so it's easier to write. And t prime is going to be right here. And h prime is going to be over here at 3 comma negative 2. And then, of course, we have to create the triangle. And the next thing the directions say is that we need to reflect it in the y-axis. Be very careful here between which is the y-axis and which is the x-axis. Some people made that mistake. But if we reflect it in the y-axis, t prime is right on the y-axis, so t double prime is also going to be right on the y-axis, and a is at 0, 0. So a double prime is also going to be at 0, 0. And then, what's this one here? Oh yeah, and h prime is 3 away from the y-axis, a line of reflection. So h double prime is also going to have to be 3 away from the y-axis, the line of reflection. So here is h double prime. And then the coordinates of those are, h double prime is 3 to the left and 2 down from the origin, so that's negative 3, negative 2. Whoops. Negative 3, does that look like a 3? Negative 2, and a double prime is still going to be right at the origin, and t double prime is going to be at 0, comma, negative 2. And I think that's it. I hope this was helpful to you guys. Let me know if it was, and I will keep doing it. If there's anything you think would be, anything you'd want me to do differently to make it helpful, let me know. And this is a work in progress, so the more feedback you give me, the more helpful I can be. Till next time.